Hi everybody in G-Block. This is the last batch of videos. They will explain the answers to the packet I gave you for Chapter 10. It starts with 10.1, where we started talking about polynomials and standard form. First, let me remind you, polynomial just means, well, poly means many, nomial, number, many numbers. So a polynomial could have 1, 2, 3, 4 sets of numbers there. Those sets of numbers are terms. Here's one that just has 2, 1, 2. In a little bit we'll see on other slides a polynomial that only has one number. Doesn't really sound like many, but what we're trying to say with polynomial is a big grab bag description for all sorts of different types of sets of numbers. The longest ones that we have here are number 6 and number 9. Both of them have 4. But the second part of the task is writing them in standard form. And standard form, well, let's do number 1 just to explain it with an example. But first of all, standard form means that you're going to, and I know my handwriting's not so easy to read, I'm trying to write, you're going to reorder the terms starting with the term that has the highest exponent. Okay, so let's look back at number 1. The highest exponent there is that 2. And so that's what we write down first, 4y squared. Looking across here next, okay, so what am I going to say is the highest exponent next? Well, this one has an x, this one doesn't. So the exponent on that x is really 1, it's just not showing. So that comes next after 2. Going downhill, the next one would be 1, so that's an exponent of 1, so the term is 3x. This doesn't even have an x or a y. So there's the degree on this, or the exponent on this, is 0, and it's going to come last. 4y squared plus 3x minus 5. By the way, I've also posted on my website these questions and the printed answers from the book, and I just looked at the printed answers and noticed that they've actually written the answer as 4x squared plus 3x minus 5. They've actually, I'm pretty sure, meant to put x squared there instead of y squared. I think this is where the typo happened. I think that was supposed to be for x squared right there. So if you were confused by that, I was for a second there too. Let's look at the next one. Hopefully that'll clarify any confusion. Number 9. Again, I'm going to write it in order, in standard form, starting with the highest exponent. Well, the exponents there's going to be 1, there it's 2, there it's 3, and there it's 0. So I'm going to start with the 3. X cubed, oops, come on back down. X cubed is going to come first, then 2x squared is the next one, then the next one is x to the first, so it's going to be minus x, and the last one is where there's no exponent at all, and that's minus 2. Okay, move on to the next examples. Here you were supposed to work with polynomials a little more. You're supposed to figure out what's the leading coefficient and classify the degree and the number of terms. Well, I'm going to go ahead and do this for a bunch of them, not just 2, but I'll actually do it for 5 different ones. Let's look at number 10, the leading coefficient. Well, there's only one number. This is a single term, a monomial. Remember, we talked about the idea that a polynomial doesn't have to have many numbers. It just means it can have many numbers. So here's one that has many. It has actually 5 terms, 1, 2, 3, 4, 5, but it's okay if it only has one term. This actually not only has one term, but it doesn't have any variables. That means it's a constant. We call it a constant because it will always be 14. There isn't anything that's going to make that change. So when there's no letter, we call it a constant. Excuse me. And number of terms, 1, means it's a monomial. So the leading coefficient for this one's 14. The degree is 0, or it's a constant. And the number of terms is 1, or it's a monomial. For number 11, the leading coefficient. The leading coefficient goes with the term that has the largest exponent. Only this one has an exponent at all. Its exponent is 1. In fact, why don't I go ahead and skip to the next one here and show you. The exponent on this one is 1. So the lead coefficient is 2. That's the coefficient in front of that term. The degree, well, that's 1. So the line, the word for that would be a linear expression. And then the last thing, the number of terms, there are 2 terms, so you can call it a binomial. For number 13, the largest degree is that 3 there. So the lead coefficient is 1. You don't see any number out in front of x cubed, but it's there, invisible. So the lead coefficient is 1. The degree is 3. You can also call that a cubic. And the number of terms is 2, so you can call that a binomial. 14. All right, the lead coefficient is going to go out in front of this degree. The degree is 4 here. So the number out in front is actually -1. I know there's no 1 showing there, but that's a -1. So that's the lead coefficient. Since the degree is 4, we don't really have a name for degree 4, so we just call those polynomials. And the number of terms, again, is 2, so it's a binomial. And, oh, I'm sorry, actually, I guess the textbook does refer to a name for a polynomial that's degree 4. It calls it a quartic. It's a word that I rarely use. And then 15. Well, this is another degree 4, so I guess we can call it, again, a quartic, so again, though I would call it a polynomial. The leading coefficient, again, it's going to be -1. There's a 1 there, even though you can't see it. And the number of terms for this one, 1, 2, 3, 4, 5, I'm going to call this a polynomial. So, moving on to the next one. You can either use a vertical or a horizontal format to add or subtract. I recommend vertical. Starting with question 31 here, I've rewritten it here, 2x cubed plus 5x, or actually I've rewritten the first expression, the one in the parens here. Well, if you're going to add this to something else, I recommend that you put in placeholders for any terms that you don't have. So you've got a degree 3, but you don't have any degree 2 here. So put in 0x squared. You do have a degree 1, so I put in the 5x, but you don't have a degree 0. You don't have a constant, so I put in plus 0. Now it's easier to line the second one up underneath. 7x squared minus x plus 2 lines up like that right below. And now it's easy to see that the 0 goes with the 7, the 5 goes with the -1, and the 0 goes with the 2. And the reason these line up is because these are both x's, these are both x squareds. I don't have an x cubed. And when I tally them up or total them up, I just have 2x cubed in this column. I've got 7x squareds in this column. 5 minus 1 means I've got 4 x's in this column, and 0 plus 2 makes 2. So this is the answer right here to question 31. One more example, and that's this one. Number 36, x squared minus x plus 3. Fortunately, this already is written not only in standard form, but there are no gaps. There's a degree 2, a degree 1, a degree 0. So it's easy to line the second one up underneath, right underneath the first one, like this. Negative 3x squared goes here under the x squared. 5x goes right under the negative x. Negative 2 goes right under the 3 here. But notice that I'm supposed to be subtracting, and that's very important. So I always really try to remind myself by making it big and bold and clear to myself that I'm subtracting this whole thing off. And what I taught you guys is, instead of subtracting, I'm going to change every sign and I'm going to add. So that's what I did. I changed that to a plus, I changed that to a plus, this which had been a plus I made a minus, and lastly I changed that to a plus. And now it's easy to tally these up underneath. X squared and 3x squared, let's move from left to right actually, makes 4x squared. Negative x and another negative 5x makes negative 6x, and 3 plus 2 makes 5. This, in green, is your answer to 36. Next set of examples, now we're moving on to lesson 10.2. I'll probably just do this slide and then I'll pause the video and start a second part. I'm going to do number 4. It asks me to multiply negative 4 times this stuff inside, the 3x and the negative 5. Well, really what I'm doing is I'm distributing that negative 4 times the two pieces. I'm going to do, there it is, negative 4 times the 3x, and I'm going to do negative 4 times the negative 5. So let's rewrite this like so. Negative 4 times 3x, and I'm going to do negative 4 times negative 5. Negative 4 times 3x becomes negative 12x. Negative 4 times 5 becomes positive 20. You put those together, and this is the answer that I'm looking for number 4. Okay, like I said, I'm going to stop the video here, and I'm going to pick up where I left off on a separate video.